On a dry hilltop in northern Chile, just before midnight on July 1st, 2025, a robotic telescope tilted its camera toward the sky and took one ordinary picture. Inside that picture, a tiny fuzzy dot was sliding past the stars. The dot was moving from the wrong direction. By morning, scientists watching the data understood what they had caught. A piece of another star system, dark and cold and ancient, had just walked into our neighborhood. If that small picture gave you a chill, you are exactly the kind of viewer this channel was built for. We chase real space mysteries, the kind where the universe quietly does something nobody saw coming, and we tell them straight, without the hype. Hit subscribe so the next one finds you before anyone else is talking about it. To understand why this moment matters, you have to know the telescope that made it. It is called ATLAS, which is short for the Asteroid Terrestrial Impact Last Alert System. ATLAS is a network of robotic telescopes, with one of the main ones sitting on a mountain in Chile, and another one on the island of Hawaii, plus others in other places around the world. Their only real job is to watch the sky for asteroids that could someday come close to Earth. So when their cameras took that picture on July 1st, the system flagged the new dot almost right away. It was a routine scan, the kind of scan ATLAS does automatically many times every night, looking for moving dots that might be dangerous. But this time, the dot was special. The ATLAS software noticed it was moving in a way that the usual asteroids do not move. Within a few hours, telescopes on different continents were pointed at the same patch of sky. Within a day, the orbit was being calculated. The math came back strange. The new dot was not circling the sun the way every planet, moon, asteroid, and regular comet does. It was moving in a nearly straight line, and that line came from far, far outside the planetary neighborhood. When something has that kind of motion, scientists use a special word for it. They call it interstellar. That is the fancy way of saying from between the stars. So this dot was not born as part of our solar system. It was made somewhere else, around some other star, and it was just passing through our sun's neighborhood the way a stranger might walk down your street without stopping to say hello. That stranger does not belong here. That stranger is just visiting. We have only confirmed 2 of these true interstellar travelers before. The first one, found in October of 2017, was given the name Oumuamua, a Hawaiian word that means scout or messenger from far away. Oumuamua looked like a stretched-out potato-shaped rock. It did not show a clear cloud of gas like a regular comet, and it did not have a clear tail, which is why scientists argued about it for years. Some thought it was a weird asteroid. Some thought it might even be something artificial, like a piece of alien technology. Most still think it was a natural object, just one built and shaped unlike anything we had seen before. The second one came in 2019, and it was named Borisov, after the astronomer who found it. Borisov behaved more like a normal comet. It had a fuzzy, glowing head of gas and a small dust tail behind it, and a lot of familiar comet chemistry. In a way, Borisov was reassuring. It told scientists that at least some interstellar visitors behave the way our own comets do. 2 examples is still a tiny collection, though. Astronomers had been quietly hoping for a third one, a clearer one, a brighter one, a visitor that our newest telescopes, tools like the James Webb Space Telescope, could finally dissect in great detail. What was found on July 1st, 2025, was officially named 3I/ATLAS. The little I stands for interstellar, the 3 means it is the third confirmed interstellar object, and Atlas honors the telescope that caught it first. It is the same kind of naming as when a butterfly species gets the name of the person who discovered it. Astronomers also use the longer catalog name C/2025N1, which is a more formal version for papers and scientific records. Now imagine what happens next. The night the discovery was announced, every major telescope on the planet started being nudged toward the new dot. Ground-based observatories in Chile, in Hawaii, in Spain, in South Africa, and elsewhere all watched from Earth. Telescopes in space joined in too, once the dot got clear of the sun's glare. The James Webb Space Telescope, usually called JWST for short, was one of the very first to take a serious look at our new visitor. JWST sits about 1 million miles away from Earth, on the night side of a point called the second Sun-Earth Lagrange point. That is just a stable parking spot in space where the gravity from the Sun and Earth balance out, so a spacecraft can stay parked there without burning much fuel. JWST carries special instruments that see infrared light, which is a kind of light invisible to our eyes but perfect for studying cold things. Comets are cold. They are made mostly of ice, dust, and frozen gases that have been sitting in the dark for billions of years. When sunlight touches a comet, those ices warm up and turn straight into gas. That gas rises off the comet like steam off a kettle, and it glows in infrared. JWST can sort that infrared glow with a tool called a spectrograph, which is basically a barcode reader for light. Each chemical gives off its own barcode, so by reading the lines, scientists can tell exactly what the comet is made of, no matter how far away it is. Here's the part people tend to remember most. What JWST saw on 3I/Atlas made the science team stop and stare at their screens for a moment. The barcode did not look like the one from Borisov. It did not look like regular comets from our own solar system either. The fuzzy, glowing cloud around the nucleus was absolutely dominated by carbon dioxide gas, the same gas we breathe out and the same gas that puts the fizz in soda. There was also water vapor and frozen carbon monoxide and methane and a curious smelly gas called carbonyl sulfide, the same chemical that gives cut grass its sharp, oniony scent. Most surprising of all was the ratio. JWST measured carbon dioxide pouring off the comet about 8 times more strongly than water. That is not a small difference. For every 1 water molecule lifting off the comet, about 8 carbon dioxide molecules lifted off too. Compare that to a normal solar system comet, where water typically wins by a wide margin. 3I/Atlas broke the rule in a way nobody was expecting. Before we keep going, here's a question for you. When you picture a comet in your head, do you imagine a glowing snowball that is mostly water and a little dust? Or do you imagine something else? Hold that picture in your mind for a second. The answer you just gave yourself is the picture most people carry. JWST may have just rewritten it. Drop the word comet in the comments so we know you are still here, and like the video so more curious people catch this story. To understand why that CO2 ratio matters so much, imagine baking 2 batches of cookies. One batch is your normal chocolate chip cookie, with just a pinch of salt. The other batch is mostly salt, with only a sprinkle of chocolate chips. Both are still cookies on the outside, but the recipe is clearly different. A comet whose head is mostly CO2 ice is the salty cookie. It tells us that wherever 3I/Atlas was born, around some other star, the conditions must have been very different from the conditions around our own sun. Maybe the temperatures were colder out where this comet formed. Maybe the mix of elements was simply not the same. Scientists are still debating the exact answer, and the debate alone is exciting for the field. JWST did not stop at carbon dioxide. The team also picked up clear signs of regular water ice, both as ice crystals and as water vapor, frozen carbon monoxide, methane, and that unusual carbonyl sulfide smell. Each one of those chemicals is a clue, the way fingerprints are clues at a scene. Putting all the clues together, scientists quickly realized 3I/Atlas is a small icy body that was cooked in a different oven, wandered the cold dark between the stars for billions of years, and then finally drifted into our sun's neighborhood. The recipe was old. The recipe was strange. The recipe was unlike anything we already had in our notes. In a follow-up study released in 2026, Webb's near-infrared spectrograph detected another strange clue, this one inside the water of the comet itself. The clear water vapor coming off 3I/Atlas carried a higher than expected amount of deuterium, which is a heavier version of hydrogen. Most hydrogen atoms are the lightest kind. Deuterium is just hydrogen with an extra tiny piece stuck inside. Older and colder objects tend to have a higher fraction of deuterium because that ratio builds up slowly over time in space. The same follow-up measurements also showed that the comet had an unusually low amount of carbon-13, which is a rare heavy form of carbon. The pair of clues, more deuterium and less carbon-13, makes 3I/Atlas look genuinely ancient. Some scientists are now floating the idea that it might be older than our sun itself, having formed in the original giant cloud of gas and dust that gave birth to many stars, including our own. That would make this little icy traveler a piece of the very early universe, dropped off in our front yard by accident. JWST and other telescopes also helped pin down the size of the thing. The solid heart of the comet, called the nucleus, is hard to measure because the fuzzy gas cloud hides it from view. Based on how bright it was and how much gas was streaming off, the best estimate is that the solid heart is somewhere around 20 kilometers across, give or take a few. 20 kilometers is bigger than most comets most people have ever seen, but it is smaller than many asteroids in our own solar system, and it is tiny compared to any planet. The fuzzy halo around it, called the coma, stretches much further in some directions, with estimates of about 40,000 kilometers across at its widest. That is about 10 times the diameter of Earth, all created by one small icy chunk tumbling through space and venting gases. The tail behind the comet can stretch even further than that, getting longer and fainter as it is pushed away by the solar wind, which is the steady stream of charged particles the sun throws out in every direction like a giant invisible fountain. Here is another detail that gives you chills, the kind most people remember years later. As 3I/Atlas was crossing the inner solar system in October of 2025, the comet lined up almost perfectly with Mars. On October 3, 2025, the comet came within about 28 million kilometers of the red planet, closer than Earth ever gets to Mars at its best opportunity. For a stretch of weeks, the comet and Mars shared the same neighborhood of space. Several spacecraft already at Mars turned their cameras toward the new visitor. NASA's Mars Reconnaissance Orbiter and the European Space Agency's Mars Express both took observations, along with other missions. Because 3I/Atlas was bright in infrared from its escaping gases, it showed up as a moving smudge against the dark of space. We had pictures of an interstellar comet taken from the close neighborhood of another planet, something that would have sounded like science fiction just a generation ago. Let that sink in for a moment. We were watching a comet from another star system swing past another planet, while our smartest machines quietly took notes. What does that feel like to you? Is it a sci-fi story? Is it a museum exhibit? Is it just a normal week in the year 2026? Type your reaction in the comments, and if you want more people to see it, share the video with a friend who still thinks outer space is empty and quiet. For the journey itself, 3I/Atlas came in from the direction of the constellation Sagittarius, the same patch of sky where the busy center of our Milky Way galaxy sits. That gave early watchers a small moment of wonder, because Sagittarius is full of old and crowded stars. As the comet fell toward the sun, it picked up speed the way any object falling into gravity does. The closer it got to the sun, the faster it moved. On October 30th, 2025, it passed the closest point to our sun, called perihelion, at about 1.4 astronomical units. An astronomical unit is the distance from Earth to the sun, which is roughly 150 million kilometers. So 3I/Atlas came within about 210 million kilometers of the sun, just inside the orbital path of Mars. That is, warm enough to wake the ices up and produce plenty of gas, but not so hot that a small comet would shatter apart. For a few weeks around perihelion, 3I/Atlas glowed brightly in infrared, spitting out carbon dioxide, water vapor, and dust into a long, familiar-looking tail that trailed behind it like a banner. It was, for that short window, the brightest interstellar visitor humanity had ever recorded from our own solar system, brighter than Oumuamua and brighter than Borisov had ever been. The next big chapter of this cosmic trip is coming on March 16, 2026, when 3I/Atlas is forecast to swing close to Jupiter. The closest approach, called a perijove, is predicted to be about 53 million kilometers. That sounds far, but Jupiter is huge, and its gravity is so strong that even at that distance, the comet will absolutely feel a pull. Scientists are already scheduling observations around that encounter, hoping to see if the giant planet's gravity tugs the comet off course even a tiny bit. NASA's Juno spacecraft, which has been studying Jupiter since 2016, may be in a position to take measurements of how the giant planet's gravity pushes on the comet. The European Space Agency's JWST mission, which is on a long path to Jupiter's icy moons, has been retasked to point some instruments at the visitor as it flies by. The first batch of JWST observations arrived back on Earth around February of 2026, and instrument teams are still going carefully through what came down, looking for any small changes in the comet's chemistry as it gets tugged by the giant planet. After Jupiter, the comet will curve back out toward the edge of the solar system. Because of the way gravity works, it will take roughly 8,137 years for 3I/Atlas to finally drift past the outermost shell of the Sun's influence, the place called the heliopause. The heliopause is the boundary where the wind from our Sun finally stops pushing back the wind from other stars. 8,000 years is longer than recorded human history. Compared to the multi-billion-year life of a comet itself, though, that is just a quick blip on the radar. For us humans alive right now, it means we have a few more years to watch this thing, and then it is gone forever. We cannot chase it. Our rockets are nowhere near fast enough to catch up to a comet that is already moving at roughly 60 kilometers every single second. By the time you finish watching this video, 3I/Atlas will have traveled a distance equal to going from New York to Tokyo 3 times over, just in the time it took to listen to these few sentences. Right now, in the middle of 2026, telescopes around the world are still tracking 3I/Atlas on its way out of the solar system. The Atacama Large Millimeter Array in Chile has been measuring the gas coming off the comet. The Hubble Space Telescope took early images back in July 2025, when the comet was about 277 million miles from Earth. The Gemini North Telescope in Hawaii caught it too, and so did many others. Even some amateur astronomers with backyard telescopes caught the fuzzy dot in the sky with the right know-how, though you would need a dark sky sight and a careful star chart to find it. Every new observation is being uploaded to public archives, and you can find them with the right searching. The science is unfolding in real time. New scientific papers about 3I/Atlas are being posted every few weeks, each one adding a small new piece to the puzzle of where this comet came from and what its home star system looked like before the sun was even born. Here is the next layer, and it is one of the most important pieces, because it shows how science actually works in real time. Scientists had a quiet assumption before JWST turned its instruments on 3I/Atlas. They expected it to look something like a slightly bigger, slightly cleaner version of Borisov. They expected lots of water, normal dust, and a normal comet tail. There was no big reason to predict a wild surprise from the third visitor. What JWST showed, and what the follow-up papers have kept confirming, is that 3I/Atlas is not a slightly bigger Borisov. It is unusually rich in carbon dioxide. Its deuterium levels are higher than expected. Its isotope ratios do not match either of the 2 earlier interstellar visitors. Each round of data moved the goalposts on the scientists, the way a court verdict can move a story in a different direction. The pattern repeated over and over again. Scientists predicted one thing, and the telescope forced them to rewrite the prediction. That matters because every time an interstellar visitor teaches us something we did not expect, we learn something new about the chemistry of other star systems. Until now, our only samples of other star systems were starlight, plus tiny bits of dust that a few special spacecraft have caught and brought back home. Now we have a whole comet, with its own chemistry, swinging past our doorstep. Even though we cannot land on it, the gases it gives off are like a free sample jar. We do not have to go to its home star. Its chemistry just happens to ride in on the sunlight, easy for us to read from our quiet blue planet. So here's a question that is on my mind right now. If 3I/Atlas was already this weird, what about the next visitor, or the one after that? Are we going to keep being surprised, or will the surprises settle down as we collect more samples from other stars? Drop your honest guess in the comments, and if you want these real stories delivered to you as they happen, hit subscribe and turn on the bell so you do not miss the next object that swings in from somewhere we have never personally been. There are still pieces of this story that nobody has solved. We do not know exactly which star 3I/Atlas came from, and we may never know for sure. The current best guess is that it has been wandering through the Milky Way for billions of years, knocked loose from its original home in some early collision between icy bodies. We do not know why it contains so much carbon dioxide, although the leading idea is that it formed in the colder outer parts of its original protoplanetary disk, where CO2 ice can survive in large amounts. If you have watched this far, you are exactly the kind of person this channel was made for. We do deep, real science stories without the clickbait, without the fake drama, just the kind of quiet wonder that the universe actually delivers on its own. Subscribe if you want more of that. Turn on the bell so you hear about the next big discovery before your friends do. Drop a comment telling me what you think 3I/Atlas was doing wherever it was originally born, and share this video with one person who would love a real story about a visitor from another star system. Thanks for staying with me all the way to the end of this one. I will see you in the next mystery.